In this video, we will see what conditional probability is. Conditional probability answers this question: what is the probability of an event happening given that some other event has already happened? Suppose if you have a standard deck of 52 cards and you draw one card, then what is the probability of drawing a king? We know that there are 4 kings in a standard deck of cards. We can write the probability of drawing a king as 4 over 52, which is equal to 1 by 30. Now, suppose someone tells you the card drawn is a face card. A face card is a jack, a queen, or a king. And every standard deck of cards has 4 jacks, 4 queens, and 4 kings. Now, if someone tells you that they have drawn a card and the card is a face card, they don't exactly tell you if it's a jack or a queen or a king. What is the probability that the card is a king? So if someone draws a card from the standard deck of cards and tells you it's a face card, now what is the probability that the card that they have drawn is a king? Earlier, our sample space was 52 cards. But when they tell you that they have drawn a face card, your sample space reduces to 12. And how's that? Because there are only 12 face cards in a standard deck of cards, and that is 4 jacks, 4 queens, and 4 kings. Now our sample space is 12 cards. Probability of getting a king given that we have drawn a face card is equal to 4 over 12. This is called the conditional probability, and this is read as probability of getting a king, and this symbol is read as given that. Given that. So the probability of getting a king given that we have drawn a face card is equal to 4 over 12. Now you may ask, why does the probability change? Why does our sample space change from 52 cards to 12 face cards? Originally, the probability of getting a king was equal to 4 by 52 because there are 4 kings in a standard deck of cards and total number of cards in a deck of cards is 52. Now, after learning that the card is a face card, the probability increased because we gained information. So conditional probability is all about updating probabilities when new information becomes available. Now, formally, we define conditional probability as probability of A given B, where A and B are events, is equal to probability of A and B, or A intersection B, divided by probability of B. This expression is read as probability of A given B, and this is read as probability of A and B. So why this formula works? Suppose event B already happened. Let's suppose event B already happened. Then our entire sample space shrinks to B. Earlier, we had a deck of 52 cards. Now, apart from having the deck of 52 cards, we are saying that we drew a card and the card drawn from the deck of cards is a face card, and we have to find out the probability that this card that we drew from the deck of cards is a king. That means we no longer have to look at all the 52 cards. We know that there are only 12 face cards in a deck of 52 cards. That's why our sample space has shrunk to 12, and we have 4 kings in the deck of cards and 12 face cards. Then probability of getting a king given that the card that we drew was a face card is equal to 4 over 12. Now let's look at an example where we roll a die. We know that sample space when we roll a die is equal to 1, 2, 3, 4, 5, and 6. That means if we roll a die, this is the set of possible outcomes. And now if we define two events, A is an event where number is even. That means event A contains all even numbers. And event B, that is in this case 2, 4, and 6. And event B is rolling a number greater than 3. And that will be equal to 4, 5, and 6. Then probability of B will be equal to 3 over 6, as there are 3 elements in the event B and total outcomes is equal to 6. Then probability of B will be equal to 3 divided by 6. We know that A is equal to 2, 4, 6, that is all even numbers. Then A intersection B, or A and B, will be equal to 4 and 6. And if we find the probability of A and B, that will be equal to number of elements in this set to or total number of outcomes, that will be equal to 2 by 6. Now to find the probability of A given B, that means probability that we have rolled an even number. When we roll a dice, the probability that the rolled dice is an even number given that the number that we rolled is greater than 3 is equal to this. And this will be equal to probability of A and B divided by probability of B, and that will be equal to 2 by 6 whole divided by 3 by 6, which is equal to 2 by 3. So that was a brief introduction about conditional probability, how we use conditional probability, what is the intuition behind conditional probability. I hope you understood. Thanks for watching.